Hi, in this video we'll have a look at D3.js. I will explain what D3.js is, why it's pretty nice to use it, and what we can do with that. Now, to learn all about that, in this video we're going to build a very simple first chart with D3.js, and we'll get there step by step to understand what it is, how it works, and how you can use it. So let's start with a very important basic question. What exactly is D3.js? D3.js is a library for manipulating documents based on data. This is a nice sentence you can find in their official documentation on their official webpage as well. What does it mean though? Well, there are two important parts in this sentence. It's a library for manipulating documents. So is it like jQuery maybe? Because jQuery, if you know that, it used to be very popular in the past. jQuery also is a JavaScript library for, in the end, manipulating documents. So manipulating the DOM, and that is what documents here means. It typically means HTML documents. So is it like jQuery? Well, we have to consider that second part here, based on data. That's the interesting part, but what does this mean? Well, D3.js allows you to manipulate documents, so it allows you to manipulate your HTML page, your DOM, but it has this strong connection to data. And in the end, it allows you to, for example, automatically render or re-render HTML and SVG elements on your page based on data you make D3.js aware of. So you can basically, you could say, connect elements on your page to data and then, for example, render multiple divs for multiple data points in your data or update the DOM when your data changes. Now that might still be relatively abstract. We'll therefore, of course, have a more detailed look at this and see concrete examples. But in a nutshell, this is what D3.js is all about. And this is how D3.js code looks like. You can, for example, reach out to a div on your page, select it, maybe select all paragraphs in there. For the moment, you see there are no paragraphs in there, but you'll see how this code works throughout this video. Then connect some data, and that is a key part. Connecting data, and then define what should happen if that data is connected for the first time or if new data was added, and for example render extra paragraph elements with some text inside of them for that data. Now that might still be very abstract, so let's maybe just dive right in and write some code. Now for that we first of all need to add D3.js to our project. And for that, we can simply grab that link we find on the official page, d3js.org, and then simply dive into a HTML document which you have. Here, I created a brand new one, a pretty empty one, just with a base skeleton, and add this import before you have your script code. So here I have the D3.js import, and here I have an import to my own app.js file where I'm going to write my own code here. So now with that, D3.js is added. Now we can write D3.js code, or we can work with it. And why don't we get started with this example here so that we can understand what happens here? For that, I'll first of all add a div here on this HTML page. So inside of the body, an empty div, just like this. And now in app.js, we can use D3. This is available because of our import here. That unlocks a global D3 object, which is now available. And you can console log D3 if you're not sure or if you want to see what's inside of that. Here, if I open my console, this is what it prints. So this is this D3.js object full of helper methods and useful functionalities. And one key thing we can do with D3 here is we can call the select method on it. Now, select does what the name implies. It allows you to select an element in your DOM. You have select to select a single element and select all to select multiple elements. Because with D3.js, and that's one of its key features and strong powers, you can actually select multiple elements at the same time and manipulate them all at the same time. And that is also another difference to jQuery, where something like this is not the main focus, at least. With D3.js, it is a core focus and it is very easy. Nonetheless, here I just want to select a div, and for that we can pass in a string with div inside of it. And what you have here in the end doesn't have to be a tag. You can have any valid CSS selector in here. So CSS class name would also be possible if you add a dot at the beginning, or by ID with the hash symbol. But I want to select by tag, and therefore div selects the first div element which it finds on the page. So now we get hold of that. Now we can do something which might look strange at first. I call select all on this, and by calling it on the selected div, I effectively would now want to select elements inside of the div. The interesting thing, of course, is that this div is empty, so there is nothing to select inside of it. Well, stick with me for now. It will make more sense in a second. Let's select, let's say, all paragraph elements in there. And as I said, I'm fully aware that at the moment there are no paragraph elements. But let's nonetheless select all elements in there. And what this gives us is again a selection. So select, just like select all, gives you a selection. And on selections, you can always call the same methods. For example, here we could again call select all to select all elements in all those paragraphs which we selected. Now, since we don't even have paragraphs here, at the moment I don't want to select anything else. Instead, now comes something important. On a selection, we can call data. In the end, to bind this selection to that data. And data here typically is an array. So for example, here 1, 2, 3, but it could also be an array full of JavaScript objects or full of strings. So now all paragraphs inside of the div are bound to this data, to this array. Now, of course, there are no paragraphs, but now comes something interesting. We can also bind elements which don't exist yet to data so that we automatically generate them when that data is there. So once we set up this binding. And we do that by now calling enter on our data, which in the end creates a new selection, which is basically a difference between the paragraphs with data that were rendered before and that should now be rendered because of this data binding. So you can basically read this as select the div, select all paragraphs in there, then bind data to that paragraph, and then tell me which paragraphs are missing. And of course, at the beginning, since we have no paragraphs in there, we got 3 missing paragraphs because we got 3 data points here, 3 elements in that array, and we're saying, please give me all the missing elements, all the missing paragraphs to which this data is bound. So enter now in the end holds information about these 3 missing elements, these 3 missing data points. And on this selection, we can now call append to append a new paragraph for every missing paragraph. So this will now in the end add the missing paragraphs to this div. This is very strange when you read it for the first time and when you hear it for the first time. But this is something you just have to get used to, and then it makes a lot of sense once you always keep in mind that D3.js is all about binding data to elements and then rendering these elements as they are required. So now we're saying, give me all the missing elements, and for every missing element, do render, do add such a paragraph. And that's, by the way, important. Just to select elements and add new DOM nodes, just for that, we wouldn't need D3.js. We could use jQuery or just the native DOM APIs, which are pretty good at this right now. But to have this data binding and make sure that we react to changes in data and so on, for this, we need D3.js, because now this simple code snippet will render 3 new paragraphs in that div, 1 for every data point here, just with this code. And if we would want to do something like this with native DOM code and so on, this would take a bit more code, especially when we then later also see how we can change that data and automatically update what's in the DOM. So now I'm not done though. I want to set some text in all those paragraphs, and we don't do this with append, but instead now with a text method, which basically takes this selection, so this paragraph, which is created multiple times, and for every created paragraph, it will now set the text inside of that. So it will add a text node inside of the paragraph element. And text either takes some static text like hello, or if you want, also a function where you get access to the data for this specific paragraph element that was rendered. 3 elements are rendered, 1 for each data point. So here data gives you access to each data point for each paragraph. And then, for example, here I can just return data in this function to basically say the paragraph, which is rendered for the first data point, should output 1 as text. The second paragraph, because the data point value is 2, should output 2. The third one, because its data point value is 3, should output 3. With all of that, if we save that and we reload here, we see 1, 2, 3 being rendered here. Now, this might not be the most exciting web app you've ever seen, but this hopefully gives you a first idea of how D3.js works. Now, typically though, you don't necessarily use D3.js to just render some text, but you can use it for that. And this is really important to me because often when people hear D3.js, they think of it as a charting library, as a library that makes it easy to render charts. Now, the thing is, indeed, you can use D3.js to render charts, and as you can see by these examples here, it's a pretty common use case. But D3.js is not limited to that. It's a general library for manipulating documents. You can render anything with it. Text, numbers, charts, shapes, whatever you want. It's not limited to charts. If you just need charts, other libraries like Chart.js might be the better choice, because those are heavily focused on charts and probably make that easier than D3.js. With D3.js, you got more power. You can build up a chart from scratch. You can fine-tune it to your requirements, and you can do more than that. But of course, that also means that you need to do more work. Now, with that said, however, let's see how we can render a basic chart if we want to. To do that, let's start with some dummy data. Now, this would be data which you in reality might be fetching from some server or from a file, but here it's just some hard-coded data so that we have some data to output. Let's say every data node has an ID, has a value, and let's say we're working with some sales data here, so maybe we have a region. Now, this is totally up to you. I'm just coming up with some fictional data here. So there we might have USA, and then we got our other 3 data points, and you could add more data points, of course. And let's say here we have India, we got China, and because I'm from Germany, we also got Germany here. But you can add more data if you want to. Now, this is the data which we, let's say, want to output in a bar chart. So a simple bar chart is what we want to render. Therefore, of course, we're not going to render a bunch of paragraphs here, but some other data. Nonetheless, before we completely remove that, if we just swap the dummy data down here for the dummy data constant I defined up here, you will see that here in this function we can now access, for example, data.region. And if we save this and I reload here, you see the regions being output here. So that's just to show you how easy it is to render nodes, elements, DOM nodes based on data. Still, that's not the main thing we want to do here. Instead, inside of that div, let's say we want to render this bar chart. For this, first of all, I'll select the div and I actually want to change its style. And that is also something you can do with D3.js. You can set the attributes and specifically also the CSS classes or the inline styles of DOM elements. For example, the inline styles can be set with the style method. The CSS classes could be attached with the classed method. But I'll go for the style method, and on that div, let's say I want to set a border to 1 pixel solid and red. And if I do that, we see nothing, or we see this here, but we don't see a real box or anything like that, because this div is missing things like a width and a height. Now, you can set everything with CSS as you're used to. I'm just using D3.js here to show you how it works. But let me also show you how we could add a class here. With the classed method, I could add my container CSS class. And now if I add a basic inline style here, let's say, just like that. And of course, you could also use a CSS file. But if I use that here, and I then have my container selector, and I give this a width of, let's say, 250 pixels and a height of 200 pixels, you will see that now I get an error simply because classed actually takes a second argument, which defines whether that class should be added or not. And here I want to add it, so I set this to true. you have this 2 argument setup so that you could change this dynamically and toggle a class, for example. But with true, this works, and now we have this nice container. Now in there, I want to render my bar chart. That's the idea. So to do that, to render the bar chart here, we need to again select the div and work with it. We need to render elements inside of the div. So first of all, I'll store that selection here in a container constant so that we can always just refer to container and work with that styled div here. Now to add some elements here, we want to select all the nodes which we eventually want to add. And that could be, for example, more divs, and then bind some data to that. Now, one important note though, if you select all divs here in the container, by default, this would select the container as well, because that also is a div and it will include that selection on which you call select all. Now, to rule that out, we could select, for example, by a CSS class like bar, and make sure that the elements we are about to render have that CSS class later. Now we can bind our dummy data here with the data method, and now again call enter to find out which data wasn't rendered yet. And when this app first loads, of course, nothing was rendered, so this will be a full selection full of 4 data points which should be rendered. So then we can append a new div here for every missing element, and on every div I want to add the bar class here so that later we can select by this. So this will now give me access to all my bars, so all the bars in the bar chart. At the moment, of course, not much is happening, but we are rendering a bunch of divs. If I reload, we don't see anything, but if we inspect this here, you'll see inside of the div there are 4 bar divs being rendered. Now, in order to make sure that we do see them, I will add a nice styling here. Since they have the bar class, we can target this. Alternatively, we could, of course, also set styles here with the style method, but I'll use CSS styles. And give every bar, let's say, a background color of 521, 751, or actually maybe a little more in this area. So a nice purple color. So 720570 is the color I'm using here. Now I'll not set the width and the height here though. Instead, I'll do this here in app.js with JavaScript. For this, we can use the attr method or also the style method. Attr would allow us to set the width attribute directly on the element. Style allows us to set the width style, which also works. And I want to set the width style, and later we want to dynamically adjust the width based on the value so that the bars are not equally sized but respect the different values. But for the moment, I'll just set the width to, let's say, 150 pixels. And not the width, sorry. The width should be, let's say, we have a total container width of 250. Since we have 4 data points, let's maybe go with 50 pixels. And the height should now be, let's say, 150 pixels. And with that, if I reload, you see this bar here, pretty large. But the reason for that is that these are all the different divs just below each other. They're not rendered side by side, they're rendered below each other. Now, of course, I want to have them next to each other, horizontally. And to achieve this, of course, here in the container, we could set display to flex and justify content space around. And if I now reload, all these bars are sitting next to each other, just because of the different CSS styling. Now, of course, this is not a realistic bar chart though, because all the bars have the same height, and we typically might want to adjust this based on the actual data point. For example, China should have the tallest bar, Germany should have the smallest. So to achieve this, we need to set the height here dynamically and not hard-coded. And the cool thing is, just as with the text earlier, where you could pass in a hard-coded value, or a function to get access to the data this DOM node is bound to, you can do the same for basically all other methods you have here, including the style method. The value which is wanted here can be a hard-coded one, or you pass in a function that gets access to the data point that is responsible for rendering this concrete div. So therefore this function will be called once for each div, and therefore in total 4 times, once for every data point. So this is the value for the data point for which a new div is being rendered, and we get access to that data. And now we could simply take that value, let's say times 15, something like this, and use this as a width. So that we use data.value. Data is the entire object, and we have a value key there. That's why we use data.value times 15, sorry. Like this, plus pixels. So plus this to convert it to a string and add pixel, because we still need a string here as a value, and that string should contain a valid CSS value. With that, if we now save this, you see bars of different height. Now, that's where we can make the next step. D3.js is great for document manipulations, and something like this is fairly easy to achieve, as you can tell. That's not a lot of code. These are just 19 lines, and 6 lines of that are just our dummy data. But D3.js is not limited to HTML, and if we switch to SVG, we are way more flexible when it comes to rendering content and to laying it out correctly. And why are we more flexible with SVG? Because with SVG, if we're rendering a SVG element and then content in that element, we actually can work in a coordinate system, which gives us a more fine-grained control over where in that coordinate system which element should be positioned. And we don't have to use CSS layout concepts like flexbox to position elements. Instead, we can use data to position elements in that coordinate system. And that's closer to what we do in charts anyways. They use coordinate systems. They use X and Y axis. So that's why you typically use SVG when you want to render charts or chart data. So for that in index.html, I will switch from div to SVG here, so that we have a SVG element here, which is still a regular HTML element, but, well, we use SVG under the hood then. And here, therefore, we select SVG. And here we don't render a div, but a rect, let's say, a rectangle. This is also a valid SVG element, which we can use inside of a SVG node. We can still give this a CSS class, this doesn't change. And we can still set the width and the height. However, we shouldn't do this with style, instead with attr. And then you also don't need to provide a string here with pixel. Instead, you can just insert a number and it will automatically be treated as pixels. If we do that, we get a slightly different result than before. We do see a bar, but it seems like all bars are on top of each other, and they're not laid out horizontally, and they also lost the color. We do see the different rectangles being rendered though, and they have the right class. Well, the color is missing because SVG elements, rectangles and so on, are not styled with background color, but with fill. Fill is simply how you set the background color, the fill color of SVG elements. We also see that flexbox has no effect here, and therefore we can remove it. There is a more elegant way of laying things out with D3.js anyways. And whilst I'm here already, I'll actually set a border of 1 pixel solid and that same purple I have down there on the container like this. And that of course means that in app.js we can get rid of this style assignment, which was just there for demo purposes anyways. So with that, they have the right color, but they're still not laid out correctly. And that's happening because of that coordinate system. Now, unlike with regular HTML elements and CSS, which we then use to lay elements out, in SVG we use that internal coordinate system, which exists in that SVG container here. And currently we're not assigning any positions to any of the rectangles in there. Therefore, they all have the same position, and that by default is the top left corner. That's, by the way, important. The coordinate system in the SVG element starts in the top left corner. Not in the bottom left, what we're typically used to from charts, but in the top left. That's why here these rectangles sit all in the top left border and actually sit on top of each other, because they all have that point, top left corner, on top of each other therefore. And that's what I said. D3.js gives us a nicer way of laying things out, because instead of styling this with CSS, which means that we have to control margin and spacing and positions in CSS, it would be nicer if we could lay everything out here, and we don't have to do this with CSS rules where we manually have to calculate things like the height and the width and maybe the positioning, but instead if we could let D3.js calculate this for us. Because after all, that is one of the reasons why we use D3.js. It's great for working with data and for helping us bring that data to the screen. And indeed, it also helps us with calculating positions of elements and so on. So that, for example, if we have 4 data points and we want to render 4 bars next to each other, D3.js helps us render things nicely positioned next to each other. Now for that, we need to bring in an extra package though. You can search for D3.js scale, because D3.js is a modular library. D3.js itself, which we already imported, just has all the core functionalities. So this package here. Then if you need functionalities that, for example, help you with scaling and with deriving positions of elements, you need to bring in the additional D3 scale package, which depends on D3.js but adds extra functionalities. To add it, you can simply grab such a link here, D3 scale v3 min in my case, and add this in your index.html file after the D3.js import before your app.js import. And we can also add the fur here to make sure that this is not getting executed too early and that this all executes in order here. So back to app.js. Now here, we should be able to set up a scaling function, which essentially is a function that helps us calculate positions of different data points that are related to each other. For that, we add a new constant, and we can name it xScale, and that should give us a function that allows us to calculate the position on the x-axis. And we call D3 scale band to basically give us an ordinal scale. So basically a scale where every item should have the same width. There also are other scales, and we will need another scale for the height, for example. But when it comes to the width, all bars should have the same width, and scale band basically gives us a uniform distribution where all items have the same width. Now, in order to let D3 calculate the width of every item, we need to let D3 know how much space is available. We do that by chaining a method here on the result of scale band, and that's the range round method. This basically tells D3.js which space is available, and it wants an array which has a from to value. So from 0 to the entire width you have available, for example. Now, we're working with a container here for our chart, and that container has a width of 250 pixels. So here we have 250 as an upper bound. And this in the end lets D3.js figure out how much space every item should have. Now, we also call another method on the result of this, and that is padding, which allows us to define a percentage padding between the items. And I'll set this to 0.1 for essentially just a tiny bit of padding between the different bars. With that, we have the x scale. Now we also want a y scale, which allows us to calculate the height of the data points dynamically. For that, we call D3 scale linear. And by the way, scale band and scale linear are methods which are only available because of this D3 scale import. So scale linear allows us to now calculate the right value, the right height, for example, for the different data points, taking into account different values for the value property. So now, unlike scale band, this will not give us the same width for every data point or the same height. Instead, it will give us different values. Now, actually, to be entirely correct, both scale band and scale linear will not give us a width and a height, but instead they give us functions that allow us to translate a value to another number. To be precise, they will give us information about the x and the y axis of where elements should be positioned. And for that, it is important to understand that with the D3 scale package, we basically give D3 information about these two axes, so x and y, and D3 will then be able to position elements along those axes. And with scale band and scale linear, we create functions that will allow us to generate positions and sizes within that coordinate system D3 will be aware of. Sounds very abstract, we'll see it in action, but that is what the scale methods here in the end will do and what the idea behind them is. And now here on scale linear, we want to call domain. And what domain does is it basically allows us to specify which min and max value we want to be able to map into our chart in this case. So we enter an array here, and now we're going to render this value, and the smallest possible value we theoretically could have is 0. So basically the x-axis should cross the y-axis at 0. This is the smallest value we want to have on the y-axis, so to say. And the biggest value, let's say, is 15, so that we have some empty space above China in this case. We could go for 12, but then the bar of China would go all the top to our chart. So to have a little bit of empty space at the top, let's use 15 here. So in the end, domain is our way of letting D3 know about the min and max values it has to deal with. So we let it know about the range of values it should be able to map into its internal coordinate system, which later is rendered to the screen. And here I'm saying my values are between 0 and 15. Please position my values, which in reality are between 6 and 12, inside of a system that has room for values down to 0 and up to 15. Because if you look at a chart anywhere, doesn't matter which kind of chart, typically, of course, the smallest value on the y-axis is not the smallest value rendered in the chart, but it typically is 0. And the biggest value on the y-axis typically is not the biggest value in the chart, but instead a value above that biggest value, so that there is a little bit of extra free space at the top. And that's in the end what we're setting up here. And then on that, we can call the range method. So not range round, but just range. And here, feed in the actual available space in pixels. And there we, of course, have a height of 200 pixels. And the important thing is that you start with the max value, so with 200, and go all the way to 0, so to the bottom. Now, we have to start with the bigger value here, 200 as a first value, because the coordinate system D3.js has in mind, so which it kind of uses behind the scenes to then later generate our positions and sizes, that coordinate system starts in the top left corner. So the position x0, y0 is in the top left, not in the bottom left as it typically is in our coordinate systems. So because of that, for the x-axis, it is left to right. There we use a range where we start at 0 and go up to our biggest value. But for the y-axis, since we start at the top and go to the bottom and not the other way around as we are used to, we have to switch those two values, and the biggest value comes first, and then we go to the smallest value. So with that, we set up x scale and y scale. And both are now simply objects and also functions which we can use to calculate concrete values for width and height based on the data point that is being rendered. We can use that down there when we render our bars. On every bar, instead of having a hard-coded width, we can call xScale.bandWidth as a function like this, all lowercase. Since every bar has the same width, we don't need to pass in any data-specific value. Instead, this will just give us, well, an equal value for every bar. And in the end, it does that by taking the available width and dividing it by the number of data points we have, taking into account some extra padding. Now for the height, it's a bit different. There, we want to keep that anonymous function, but we're going to use something from the data now to translate it into an actual height in pixels that takes into account the available range, but also our theoretical min and max values here. And to do that, we just call yscale here as a function, and we pass in data dot value as a, well, value, and this will translate it into an actual value that's being rendered. If we now reload, we see something, but it looks like all the bars are now simply stacked on top of each other. And there's a good reason for that. Currently, they all have the same width. And they shouldn't have that, of course, because of my scaling here. And certainly they shouldn't all take the total amount of width, the total available width. Well, that they all take the total amount of width is my error. We also have to specify a domain here for x scale to basically let the scaling function know how many data points we have. And we do that by using our dummy data here, and then by calling map on this. And for every data point we get out of there, we can just access the region field. And that basically means we have now an array full of strings, which now is that array of unique data points we need here for domain so that the scaling function knows how many items we'll have in total. If we do that and reload, now at least the width is correct. They're still all on top of each other, but now every bar has a width that is small enough to theoretically fit 4 bars next to each other into our chart. However, of course, they should be next to each other and not on top of each other. So to ensure that, we now don't just need to set the width and the height, but also the x and the y attribute, which we can do on SVG elements like our rectangle. And we again set x and y with help of our scaling functions. So here we again pass in the function so that we get access to the data point for which this rectangle was rendered. And for x, I want to call x scale and feed in data.region because I used my regions here as my domain for the x scale. So D3.js is aware of these 4 region names here. And now by passing in a region here again, it knows which data point it is for which it should position the item, and it automatically will position it correctly along this available range here. And we do something similar for y. There, I pass in my data, and I call y scale here, and pass in data.value, so that it knows where to position this on the y-axis. And if we now reload, this looks interesting, but now at least we see 4 different bars. Now, why does this look interesting here? It looks the way it looks like because our height is actually calculated incorrectly. If we change our height here to be the maximum available height, so 200 in our case here, minus the calculated y-scale value, now it looks the way it should look like. And the reason why we have to do this is simply that by default, the coordinate system for D3 does not start in the bottom left corner, but in the top left corner. So therefore, everything is calculated from the top left. And that means that since we start at the top and not at the bottom, we calculate the actual height by taking our max height and reducing it by that calculated value here on the y scale. So with that, we now got a nicer bar chart here with D3.js. Now, especially that scaling thing is definitely something you need to get used to, but here practice is everything. The more you work with that, the more charts you build, the easier it gets. And in the end, what you learned here about x and y scale and this code you see here, that already is some code you're going to use a lot. You also, of course, have the GitHub repository of the D3 scale package, where you can dive deeper and learn all about the different scales you have there and how to use them. To understand this positioning better, you can also simply manipulate those values here. So as I said, we start on the top left corner, and the y-scale function, for example, simply gives us the y-axis position of this rectangle here. And it takes the concrete value into account to give us the right position in relation to the other elements that are being rendered. So for example here, this first bar, the leftmost one, which is for the USA, has a y value of 66.66666 and so on. If we set this to 0 here in the dev tools, you see it's all the way at the top, which basically proves the point that we, well, start in the top left corner. x0, y0 would be exactly in the top left corner. Now we had x8 here because of the extra padding that was set up, and that's all taken into account automatically by D3.js. And we had y66 and so on because of the y position we derived based on the value. Now that shows you why you of course have to calculate the height by deducting that from the available height. Because then you basically render a rectangle which has a height of 200 minus the space that should be empty because it's the space from the y-axis at the top to the beginning of the bar if we look at it from the top. So this empty space here, that should stay empty, and that is the distance between the top, which is 0, and the starting point of our rectangle, which is 66.6666 and so on. So y scale and x scale, if you call them, those functions, don't calculate widths or heights, they actually just calculate positions inside of that coordinate system D3.js uses behind the scenes. And it's then up to you to translate these positions into, for example, a height as we're doing it here. Now for the width, we have this bandwidth function which we can call on x scale to get this equal width for all the bars. But for the height, we take the position from the top and deduct this from our total height which we have available to get the height of the bar we want to have from bottom to the top. So once you think about it like this also shouldn't be too mysterious and hard to grasp. Now with that, of course there's more you can do. You could add an axis, you could do other things, but I'll leave it at there for now. Was a long video already. I hope I at least could get you started with D3.js and explain roughly what it does and what differences to jQuery and so on are, and that it's not just for charts. And I hope that this basic functionality is clear. Now there is just one thing which I also want to dive in before I really finish the video, and that's that select all thing here, which I did before I added data. I mentioned that I do this even if nothing was rendered before. And the reason for that is actually that we now bound data to those bars. And yes, initially we have no such bars, but that changes once such bars were rendered. And you can see the effect of that if you actually add, let's say, a set timeout function down there, where you set a timer of, let's say, 2 seconds to then execute this function. And in there, I'm going to use my bars here, the bars which were rendered here. And I'll set my bars to some new data, which is, let's say, my dummy data, but with the slice data, I'm only going to take a part of it, only the first 2 items, let's say, so that it's not the full array, but half the data. Now, if I do that, I can call exit on this, and exit is basically the opposite to enter. Enter gave me all the missing elements, which were not rendered yet. Exit gives me all the elements that are too much, that should be removed, based on the new data I'm feeding in. And it's not taking any elements that are too much, it's looking at with which data the elements were rendered and which data is still there, and just give me the elements that were rendered, but for which the data is not there anymore. And then we can call remove on that selection to remove all those elements from the DOM. And with this, if we save this and reload, you will see that after 2 seconds, the last 2 bars disappeared because they're not part of the rendered data anymore. And this shows why we have to select bars here. I'm using bars, which is this constant, which is this entire selection, which in the end are the rendered bars. But if I wouldn't select bars here, this would not work. If I would remove that code, nothing would actually work here. It wouldn't be rendered at all. And the reason for that is that D3.js would not work which concrete elements, even if they're not yet on the DOM, will be tied to the data. It's not the container that's tied to the data. The elements inside of the container are connected to the data instead. That's why we have to select them, even if they're not there yet, so that D3.js knows which values will eventually be there, because it can only tell me which data is missing or too much if it knows which data should be there, so which elements it should find. And if we just say, hey, have a look at the container, well, we do have one container here, We then try to render more rectangles based on missing data, but the container is no such rectangle, so that doesn't work out. That's why select all matters here.